Number 11, we are graphing in vertex form. So that means we are dealing with our y equals a times x minus h squared plus k. Okay, our vertex is always found by h comma k. Our axis of symmetry is always x equals h. Okay, so those are the pieces we need to know. So if we look up here, our a value is in front of the parentheses, so our a value is 1. H is always the opposite sign because of that subtraction. So our h is going to be -4. Our k is -1. So our vertex on this problem is h comma k, -4, -1. The axis of symmetry has to have x equals. It has to. So it's x equals our h value, which is -4. And the direction that this parabola is going to open is up because a is +1. Okay, so to graph this, we're going to plot the point -4, -1. Okay, we know there's this sort of invisible line right here that's splitting this in half. That's our axis of symmetry. And we know that every time we go over, we do whatever the number squared is. So 1 squared is 1, 2 squared is 4. So from the vertex, I'm going over 1, and then I want to account for that 1, and this tells me the direction. So over 1, up 1. And then from the vertex, again, I'm doing the same thing. So from the vertex, over 2, and then I'm going up 4. Okay, if I went over 3, I would go up 9. Now I mirror that on the exact opposite side. So over 1, up 1, over 2, up 4. Make sure you draw your parabola in and make sure you extend those lines. Okay. Then when we name a point and a symmetric point, right, those are points that would fold on top of each other. So you can pick either of these points. You just need to pick one that then has a matching point that it would fall on top of. So if I pick this point right here, this is the point -3, 0. Its symmetric point is the one that it would fold on top of. So whatever's on the exact opposite side of it, so that would be -5, 0. Now you could have also picked -2, +3, and then paired that up, 2, 3, 4, 5, 6, -6, 3. Number 12 is the same idea, right? So we want to find that a, h, and k. So we know here that a equals -1. H is the opposite of what it looks like, so +3. And k is -6. So our vertex is always h comma k. So in this situation, 3, -6. Our axis of symmetry is always x equals h. So again, x equals has to be there. Our h is 3. Okay, our a value here is -1, so we know that this is going to open down. Okay, so we're going to plot the point 3, -6. Okay, then we're going to do our same pattern as above. So we're going to go over 1, but this is telling us to go down 1. So over 1, down 1. Again, from the vertex, over 2, down 4. And then we repeat that same process on the other side. So there's our parabola. So for our point and a symmetric point, so if I name this point first, I'd have 2, -7 and 4, -7, right? I'm just naming that point. Over 2, down 7. But I could have also just as easily picked 1, -10 and 5, -10. Doesn't matter which one of these you put first. You could have those flip-flopped either way. 13 and 14, we are doing that in reverse order. So we are writing the equation of the line given the graph. So we want to fill in our blanks for a, h, and k. So a is determined if the parabola opens up or down. So this parabola opens up, so that's going to be a +1. Our h and k are found from the vertex. So this vertex has a point of 1, 2. Right? It's h, k. So our h is always the opposite sign. So it looks like a +1, so I'm putting in a -1, right? And that's really because the formula has that negative in there, that subtraction in there. And then my k is +2. So number 14, if we do that same idea, right, we're filling in A, H, and K. This parabola opens down, so our A is going to be -1. This point is -3, -1. So this ends up looking the opposite, so a +3 and a -1.